Okay, today we're going to talk about inverse functions. The first thing we need to do is discuss what is a one-to-one function. A function is one-to-one if a is not equal to b, then f of a is not equal to b, and if f of a is equal to f of b, then a is equal to b. So it's easier to look at it with an example. Basically, if a function is one-to-one, then the y values cannot repeat. Okay? So if you'll remember, if a relation is a function, then the x values can't repeat. If a function is one-to-one, then the y values can't repeat. And so we'll talk about what that means to us in terms of inverse here shortly. But so we need to look at the y values of this function, and you can see that there are two ones in the y values. So that means that this function is not one-to-one. Ugh. Okay, same thing here. If there are two y values, or if you had, say, two things going to the same, mapping to the same bubble for our y values. But in this case, we do not. There's only one arrow going to each y value, so that means that we are one-to-one. In this case, one way we can test to see if something's one-to-one is similar to the way we test to see if a relation is a function. If a relation is a function, then you can draw a vertical line through the relation and it will not hit more than once. Same thing with one-to-one, only it's with a horizontal line. So we can draw a horizontal line through any of these points and it won't touch more than one point through one horizontal line. So in this case it doesn't, so this is a one-to-one function. Example 4, draw a horizontal line. It's pretty obvious this one is not one-to-one. And here, if we draw a horizontal line anywhere on here, we're good to go. So this function is one-to-one. For example 6, a little bit different. Use the definition of one-to-one to determine whether this function is one-to-one. So basically, we're showing that if f of a is equal to f of b, then a equals b. What does that mean? Well, we plug in a for x and b for x. So we'll do 3a plus 2 and 3b plus 2. If this comes out down at the end so that a equals b, then that means that we have a one-to-one function. Okay? So subtract 2 from both sides, and we've got 3a equals 3b. Divide 3 from both sides, a equals b. So we do have a one-to-one function, or the function 3x plus 2 is one-to-one. Let's try the same thing with example 7. Okay? Let's think about it first. 3x squared. The last one was a line. Okay? We know we can draw a horizontal line through a line it's only going to hit once. 3x squared, that's a parabola. So if we draw a horizontal line through it, it's somewhere on the graph it's going to hit twice. So this one's probably not going to work out, but let's check and make sure. So we've got to see is f of a equal to f of b. So 3a squared, is that equal to 3b squared? Divide both sides by 3. And we've got a squared equals b squared. Well, if we take the square root of both sides, you think, well, a equals b. Problem is, one of those has got to be negative. So, in this case, we do not have a one-to-one function. Okay, why is one-to-one important? Because if a function is one-to-one, then that means it has an inverse. And what is an inverse? An inverse means that, it's kind of not explained too well right there. Let's look at a picture. An inverse means that if you've got we'll try that, a function, for every x that equals y, y equals x. Or it is symmetric to the line y equals x. So in my picture here, the green function and the purple function are inverses. And notice they are both one-to-one, otherwise they wouldn't be able to have an inverse. So one way that we can test for inverse functions is that if f of g of x, that's what this means, f dot g of x, if f of g of x equals x and g of f of x equals x, then they're inverses. Okay? So that's a fairly simple way for us to check to see if a function if two functions are inverses of each other. So we're going to take f of g of x. Remember, we've done this before. So f of g of x is 1/3 x minus 2. So we've got 3 times 1/3 x minus 2 plus 6. Distribute the 3. There's supposed to be an x right there. Oops, not there. Okay, and so we've got x minus 6 plus 6, which is x. Awesome. So now we test g of f of x. And so we've got, let's write it out one more time, g of f of x, which is 3x plus 6. And so we've got 1/3 times 3x plus 6 minus 2. Distribute the 1/3, so we've got x plus 2 minus 2, that gives us x. So that means that yes, these functions are inverses of each other. Okay? Okay, determine whether these two functions are inverses. So, I think there's supposed to be an f right there, obviously. So we've got f of g of x and so that's g of x goes into f of x. So we've got 5x plus 1 plus 1, and those parentheses, there's nothing to distribute or anything, so we don't have to worry about them. So we've got 5x over 5, which is x. Okay, but we've got to test g of f of x also. So we've got 5 times x plus 1 over 5 plus 1. Okay? So if we distribute our 5, then the 5's cancel out. And we've got x plus 1 plus 1, which is x plus 2. Well, that didn't give us x. It gave us x plus 2. So no, even though this one gave us x, the other one didn't. So that's why you've got to test both. So no, these two functions are not inverses of each other. Okay? Next, how do we write a function that is an inverse of another? Well, it's not that difficult, luckily. So here you've got y equals 2 plus 1/2 x, right? Okay, so to write the inverse, to find the inverse, we switch x and y, because we said a little while ago that we are symmetric to the line y equals x, and so for every x that's equal to y, y is equal to x. So we just switch. So we say x equals 2 plus 1/2 y, and we solve it for y. So 1/2 y, subtract 2 from both sides, is x minus 2, and then multiply everything by 2. 2x minus 4 is our inverse function. Now, how do we denote that? F of x is equal to 2 plus 1/2 x. Well, the inverse, we say f to the negative 1 of x is equal to 2x minus 4. Now, we're not really going to the negative 1 power or anything, okay? So don't think that it's an exponent like that. That's just how it's denoted. And if we graph this, if I get it to be straight, then you can see if we graph the line y equals x, yes, it does flip along that line. Of course, let's see if I can make this look a little bit better. There we go. They'll cross right there. That looks a little bit better. Okay, so if we graph the line y equals x, you can see that they do flip along that line. There we go. Okay, so let's look at a few more examples like that. Okay, so here we've got f of x is equal to 3x over x plus 1. So that's the same thing as y equals 3x over x plus 1. So we switch. X equals 3y over y plus 1. And then we need to solve for y. So we're going to multiply both sides by y plus 1. Okay? And go ahead and distribute the x. And what we need to do here to solve for y is to get the y's on one side. So I'm going to start by subtracting 3y from both sides. And at the same time, I'm going to go ahead and subtract this x here from both sides. So that's going to give me xy minus 3y equals negative x. Then I can factor out our y, and that will give me, did I do that right? Yeah. That will allow me to solve for y. So we have y equals negative x over x minus 3. Something's not right. I've got to... Oh, okay. I just switched it around the other time. Okay, so we can say that the inverse function is negative x over x minus 3. And if we graph that, there it is, you can see that everything has flipped, okay, along the line y equals x. Okay, for this one, same type deal. So here we've got y equals x squared. So we need to switch. X equals y squared. To solve for y, it's plus 3. Okay, so to solve for y, let's first get the y by itself. So we got y squared equals, I'm subtracting 3 from both sides, so x minus 3. And then take the square root. So we've got plus or minus the square root of x minus 3. So the inverse function is we need, this is for x is greater than or equal to 0. The inverse function here cannot be positive or negative. If we graph positive or negative, then it's not a function. Okay, it looks something like that. So it can only be the positive part, only positive x minus 3, square root of x minus 3. Okay, and there it is. And then our last one, we're just graphing the inverse function. So this is pretty simple. Since this first point here is negative 4, negative 2, then its inverse is negative 2, negative 4. And so we graph it, negative 2, negative 4, right there. Okay? The next point is negative 3, 1. So its inverse is 1, negative 3. The next point is 1, 2, or no, it's not. It's negative 1, 2. So its inverse is 2, negative 1. And last we have 1, 4. Switch the x and y. Its inverse is 4, 1. And so our inverse function would look like this. And that concludes section 3.1 on inverse functions.